Hi, Anthony Carruthers, Better Lesson Master Teacher Project, and in this part of the lesson we'll be proving case 1 of the inscribed angles theorem. This is the case in which the side of the angle passes through the center of the circle as shown here. So to get things started, we'll want to introduce an auxiliary segment, and that auxiliary segment is going to go from point A to point O. So you'll notice that it's a dashed segment, and this is to emphasize that it's an auxiliary. One of the overarching themes of this lesson is the power of auxiliary segments, so I want to explain to students how I carefully choose auxiliary segments. So for this particular one, basically I want to explain to students that it accomplishes a number of things. First of all, what it does is it creates a central angle, which I'm going to name angle 1, and that central angle has the same intercepted arc AC, as the inscribed angle does. And I'm going to call that inscribed angle angle 2. Okay. The second thing that it accomplishes is that it brings the triangle exterior angle theorem into play. So you'll notice that angles 1, 2, and 3 are exactly the components of the triangle exterior angle theorem. So I want to have students talk that up in their partners, their AB pairs, as to what is accomplished by this auxiliary segment. So again, I would tell them, but to make sure that they've heard it and processed it, I'd have them discuss it also. So once we've done that, we'll want to actually begin working on the proof. So basically what I'm trying to prove is that the measure of angle 2 is half the measure of arc AC. So if we wanted to, I could just go ahead and replace this here. Instead of saying measure of angle B, I'll say measure of angle 2. And let's move this out of the way. Okay, so these are just going to be the key steps of the proof. I will not be writing out the entire proof for the students. I'll have them do that at a later time, but here I just want them to understand the major steps and the reasoning behind them. So to begin, I suppose I would start by saying that triangle AOB is isosceles, and I want to have students discuss why that's true. So again, triangle AOB is isosceles, not circle, sorry. Triangle AOB is isosceles. So again, I have students get into their AB pairs and explain to each other why AOB is an isosceles triangle. And we would get to the fact that OB and OA are radii. And because of that relationship, all radii being congruent, that makes this an isosceles triangle. The next thing that I want to bring out, because triangle AOB is an isosceles triangle, then we know that measure of angle 2 is equal to measure of angle 3. Okay, that's just the isosceles triangle base angles theorem. And based on that, I'll want to start now dealing with the triangle exterior angle theorem. So the triangle exterior angle theorem, and again, I'll probably be asking students to tell me what it says, but we will get to the fact that measure of angle 2 plus measure of angle 3 must equal measure of angle 1. Okay, so at this point we have some things to work with. So ultimately I'm trying to relate angle 2 to angle 1, so I can kind of forecast and know that measure of angle 3 should not be part of the final conclusion, which if I look around I can see that measure of angle 2 can be substituted for measure of angle 3. So that's what I'll do in the next step. So to do that, I'm going to copy this, and the reason for copying it is so that students can kind of see how one statement morphs into the next. So instead of measure of angle 3, here we're going to put measure of angle 2 because measure of angle 2 can be substituted for measure of angle 3. Okay, again, keeping with that theme of one statement morphing into the next, that theme rather, I'm going to copy this and paste it. And instead of writing measure of angle 2 twice like this, I could just get rid of one of those and then call this 2 times measure of angle 2. Okay, so again, we're going to show how this flows into the next statement. So I'm going to copy it and paste it. And we can see that dividing both sides by 2, that will get rid of this. And here in front of measure of angle 1, I can put 1/2. Okay. And so we're pretty close to what we were trying to prove. So we have measure of angle 2 equals 1/2 measure of angle 1, but we wanted measure of angle 2 equals 1/2 measure of arc AC. Well, what we do know is that measure of arc AC is equal to the measure of angle 1. So measure of angle 1 equal to measure of arc AC. Okay, and of course that comes from the postulate that we established in the first part of this lesson. So now we're at the final stages where we can take this statement here, and again, keeping with the copy and paste theme, we're going to take this statement, copy and paste it, okay. And instead of measure of angle 1, so I want to take that out, and instead put measure of arc AC. Okay, so now we basically shown the key steps for proving that the measure of angle 2 an inscribed angle is equal to the measure of arc AC, which is its intercepted arc. So students at this time would have opportunity to ask questions about these key steps, and then we move towards having them actually write the proof more formally in a paragraph proof or in a 2-column proof or even a flow proof. Okay, Anthony Carruthers, Better Lesson, Master Teacher Project.